A very good morning to the audience and participants. I, Professor Mohua Datta, the moderator of today's session, with Mr. Jeet Biswas and Professor Gautam Das, the web hosts, welcome you all to the second day of our national conference, Development in Engineering Education and Practices, organized by Elite College of Engineering. I hope all of you have enjoyed our last day, that is inaugural session, as well as our first technical session. So let's get into the second technical session of today, which is based on emerging trends in civil engineering. And the honorable keynote speaker of today's session is Professor Dr. Sudhir Basak. I would like to ask the web host whether I am clearly visible and audible. Gautam sir and Jeet sir, please unmute yourself and tell me.
Yes, ma'am. That's really and audible.
Okay. Thank you so much. So before Dr. Basak starts addressing the audience with his presentation on the topic soft ground improvement by granular reinforcement for transport infrastructure, I would like to introduce him to the audience. Professor Dr. Sudhir Basak is a civil engineering professional with vast academic experience at responsible senior positions in India and abroad. He published more than 125 technical papers in reputed journals and conferences, and is recipient of several research awards at national and international levels. He is an active editor and reviewer of numerous top-class international journals. He has supervised more than 10 research students at postgraduate and PhD levels and executed sponsored research projects in different universities. He has undertaken several academic visits in many countries, including USA, UK, Germany, Australia, New Zealand, Singapore, China, etc. But what is not written formal introduction, I must say that our principal sir, Dr. Sudhir Basak, is the main driving force of this conference, TEEP 2022, and he is the patron of this conference. He is the most respected principal of Elite College of Engineering. I think sir is already present among us. I would like to invite sir on this platform. Over to sir. No, sir. Actually, I cannot hear you. Gautam sir and Jit sir, can you hear sir?
Okay. So can you hear me?
Yes, sir. Now we can hear you.
Yes, it's audible, sir.
Yes.
Yes.
Okay. Right. Okay. Thank you, moderator, for your nice words. So I should add that every one of us worked very hard, not only me, but everyone worked very hard to make this conference a reality. So thank you, everyone, all the members of the organizing committee and all the stakeholders. So a very good morning to everyone. So let me start my presentation formally. And from yesterday's experience, we were half an hour late behind our schedule in the first technical session. So I shall try to limit my presentation within 45 minutes. And after that, we can take questions. Right. So without much stretching my words, I should start the presentation. So first, let me try. So if not, so I will request the organizers to play the presentation on my behalf. Thank you. So let me try. Okay, so can you see the slide?
Yes, sir.
So is it in the full screen mode?
No, no, not yet.
Okay. Okay. Is it in the full screen mode?
Still not, sir.
Okay. Okay. Right. Right. So that is the main problem. Okay. That's not an issue. Right. So let me play the PDF file first. I guess the PDF file will be right. Okay. Okay.
Yes,
So is
sir.
it
Now, yes, yes,
is it
yes.
in the full screen mode, right?
Yes, sir.
Okay.
Hmm.
So good morning, a very good morning, ladies and gentlemen. So now I am clearly visible and audible, and my slides are, I'm fortunate that my slides are also clearly visible, right? In full screen mode. So that's a very good thing. So the topic of presentation is soft ground improvement with granular reinforcement for transport infrastructure, right? So this was a research project which we conducted when I was an academic staff in Australian University, University of Wollongong. I was an academic staff. So we performed this research project with the help of my students and PhD scholars. So soft ground improvement. So first let us try to understand the title of this presentation. What is soft ground? Soft ground is something, some soil, whenever it is soft and compressible. In most of the cases, the soil is clay soil and it is saturated. So in India, in the eastern and western coastal belts, okay, the Konkan and Coromandel coastal belts, okay, the soil in the coastal regions and in the offshore regions near the coast, they are soft and compressible. Moreover, in the alluvial plains in India, Gangetic alluvial plains or other alluvial plains, they are soft and compressible soil. For example, the normal Calcutta soil, which we called Ganga Mati, that is also soft compressible soil, right? So in many parts of the world, it has soft and compressible soil. And if you want to build a structure, for example, a building or a bridge or any other structure, if you want to build on this soft and compressible soil, the collapse will take place of the structure. So you cannot build. Okay. So that is the difficulty. So there comes the necessity of improving the ground. Okay. You are improving the ground means you are increasing the strength and stiffness of this soft soil. That is called soft ground improvement. Now there are various techniques for soft ground improvement. Okay. One of the technique is granular reinforcement. Let us try to understand what is granular reinforcement. It is nothing but a vertical drain hole which is bored through the soft soil deposit or soft soil layer. Whenever we bore a group of, you can see below, the first photograph is about a train moving, second photograph are a group of vertical lines. Okay, so these are the vertical group of vertical drains which are bored through the soft soil deposit, and it is filled with coarse aggregate or stone particles. Okay, so that is called granular reinforcement. So how the soft soil is improved, that we will discuss later on, right? So this is called soft ground improvement with granular reinforcement, right? And in case of transport infrastructure, let us try to understand this. What is transport infrastructure? So transport infrastructure is nothing but highways, railways, or port and harbor structures, or in some cases airports, even the airports. Okay, even the hyperloop, the most modern thing is hyperloop. They are all transport infrastructure. Okay, So whenever a transport infrastructure is supported or is extended over a soft clay deposit, okay, so it will not be able to perform because the vehicles move on this transport infrastructure. For example, in the photograph below, the left hand side, you can see a train is moving on a soft ground. Okay, because the train is moving, a cyclic and dynamic load is imparted on the soft clay deposit. Okay, so whenever the soft clay deposit is subjected to dynamic loading and cyclic loading, what happens? The water inside the soil is pressurized and an excess pore water pressure is generated. Okay, due to which the bearing capacity of the soil is progressively and gradually decreases and the transport infrastructure collapses. That is the problem. Okay, so our research project was focused to solve this problem through granular reinforcement. Okay, let us come to the next slide. Can you see the next slide? I think you can
Yes,
see
sir.
the next slide. Right.
Yes, sir.
So it shows the content of presentation. First comes the background information, then the analytical and numerical modeling, then comes the laboratory model study, then field-based investigations, and finally the important conclusions drawn therefrom. This is the basic structure of this presentation. Now let us understand what is stone column reinforcement. We see granular reinforcement and it is filled up with stone particles or coarse aggregate. Therefore, it is called stone column reinforcement. Okay. So how does it act to improve the soft soil is the question now. Let us try to understand. It acts as a vertical reinforcement. So what is reinforcement? You know, reinforced cement concrete. Okay. Inside the concrete there are bars, steel bars. So for example, there is a column. Okay. There is a reinforced cement concrete column. Right. So without the reinforcing bar, without the steel bar, the load, in order to sustain the load, we need a higher cross section of the concrete. Right. But whenever we apply the steel bars, the steel bar takes the most of the imposed loading and the overall cross section is reduced. So there is a cost reduction. Okay. Similarly, this stone column reinforcement acts as a vertical reinforcement because it possesses greater strength and stiffness compared to the surrounding soil. Right. So these columns bears the majority of the imposed load from the superstructure. But not only that, they also assist in acceleration in radial consolidation. Okay, so you know, all civil engineers here, they know that whenever loading is imparted, applied on the soft clay layer, soft clay deposit, the water squeeze out. Okay, the water squeeze out. For example, in our college, after a heavy rainfall, we have a playground, and if you walk on the playground, what happens? You see water is coming out from the soil because the soil becomes soft due to the heavy rain. And so that is called consolidation. Okay. So whenever this reinforced soft clay is subjected to imposed loading, consolidation takes place, that is squeezing out of water. Due to the existing of these vertical boreholes filled with granular reinforcement or stone particles, okay, so the water comes out through these vertical drains. Okay. As the water comes out, the soil gradually gets stiffened. This is called consolidation. So this stone column reinforcement, they speed up the excess pore water pressure dissipation. Okay. So the advantages of this stone column is that it dissipates excess pore water pressure, okay, faster than the PVDs due to large diameter and higher hydraulic conductivity. Right. So what is PVD? It is nothing but prefabricated vertical drains. So what is that? So instead of stone particles, if we fill up these vertical drains by means of jute fibers, so it is called prefabricated vertical drains. Okay. So jute is also hydraulically it is conductive, so they drain the water. So whenever it is filled up with jute fabrics, it is called prefabricated vertical drains. So instead of these jute fibers, if we fill up these boreholes by sand, Sand is also hydraulically conductive. So whenever it is filled with sand, it is called sand compaction piles, right? And whenever it is filled with coarse aggregate or stone particles, it is called stone columns, right? So the stone columns has larger diameter and higher hydraulic conductivity because the stone particles are of higher size. So due to which the drainage is much faster. Okay, and also effective load transfer mechanism while environmental friendly compared to pile foundation. Let us try to understand this. So what is effective load transfer mechanism? So if we fill up with sand or jute fibers, they doesn't possess a greater strength and stiffness. Okay, so that is a problem. So in case of stone columns, it possesses higher, greater strength. Okay, compared to PVDs and sand compaction piles. So the load transfer mechanism is quite effective. And also environmental friendly. What is that? So pile foundation, whenever it is installed in the soft ground, they effectively transfer the superimposed load. Okay, but this pile foundation has to be manufactured in the stackyard in the site. So that creates a lot of carbon emission and lot of environmental pollution. So in case of stone column installation, no such problem arises. Third one is reduction in excess pore water pressure buildup under cyclic loading. So as you see, whenever we walk on soft clay, suppose in our college campus on the playground after a heavy rainfall, we are walking. So we are imparting a cyclic and dynamic loading on the playground surface. Okay, due to which water comes out because gradually the water pressure is built up. Pore water pressure, excess pore water pressure is built up under cyclic loading, and due to which the bearing capacity reduces. Okay, and stone column is very effective in dissipating this excess pore water pressure, right? So without going into much details, let us proceed to the next slide. So you see there is a load transfer mechanism. You can see this is the pair of stone columns and this is the soft clay zone, and the soft clay surface is settled like this and the stone column settlement is much less. So this phenomenon is called arching, right? And this arching initiates a vertical stress distribution which is non-uniform on the ground surface. Okay, so the equation, mathematical equation is parabolic. So I'm not going into the mathematical details. So phenomenon of clogging. So stone columns has a problem which is clogging. What is clogging? Whenever water flows from the soft clay towards the column, okay, water is flowing. So with water, the clay particles, very fine clay particles, they also migrate from the soil to the stone columns and they get deposited in the pore spaces of the coarse aggregate, due to which the overall drainage pattern and drainage facility of the stone column is reduced. So this problem is called clogging. This is a very adverse problem. Okay, and we have studied this. So next is effect of smear. What is smear? So whenever these stone columns are inserted in the ground surface, okay, you can see the previous slide, this slide. So the stone columns are installed. Okay, these are the stone columns and we are installing the stone columns. So due to the installation process, the surrounding soil gets disturbed and their permeability and compressibility is gradually reduced. This is called smear. Okay, so this is the stone column zone. As you can see the horizontal cross section of a typical stone column. This is the column, smear zone and undisturbed zone. These two are soil zones. This is a smear zone, that is the disturbed zone. Okay, in this disturbed zone, the permeability as well as compressibility decreases. Okay, there are several literatures available, and Weber et al. 2010 they found for X-ray tomographic studies, they found that there are three distinct zones in this smear zone, that is penetration zone, smear zone, and densification zone, right? So how we focused our research project, right? So what are the industry oriented problems? Okay, because the problems are reported by the industries, okay, to the universities, and universities solve the problem. That is the basic idea, okay, in Australia and any other foreign countries, right? So industry-oriented problems are there. The optimum column geometry and material specifications. That means what will be the diameter of the stone columns? How much will be the depth of penetration of the stone columns? What will be the center to center spacing of the stone columns? And in what pattern will it be distributed? Whether it will be triangular, hexagonal, or square pattern, right? Or zigzag pattern. Okay, this is a column geometry. And material specification means what will be the size and shape of the stone particles or coarse aggregate. So this is a problem. Nobody knows what is the optimum values. Next one is influence of lateral deformation. So whenever vertical load is imparted, some lateral deformation of the stone column takes place. So this initiates some problem. Okay. Third one is this clogging problem. Okay. And the fourth one is imparting cyclic load at higher frequency. Okay. This creates some adverse effect on the soil. So these were basically the four problems. And what are the research methodology that was applied? Through laboratory model tests, analytical and numerical studies, and field-based investigations, right? So first comes the analytical and numerical modeling. So you see in this left-hand side figure, this is the numerical model where we performed a computational work through fully penetrated column, unit cell analogy, and the freestanding hypothesis was considered. The arching, clogging, and smear effects were taken into consideration, and we adopted modified Camp-Clay theory. And the computational technique adopted was first Lagrangian finite difference technique. Okay, so this is the basically the finite difference discretization of the problem which was adopted. So the studies aspects were vertical stress distribution of ground surface, time-dependent consolidation and settlement characteristics, degree of ground improvement characteristics, and development of some design curves. These are the four study aspects that was conducted through this numerical study, through this computer program, right? So first comes the radial consolidation. So this is purely mathematics, which I don't want to interfere much, but if this is a column and this is a soil zone, so this is a typical vertical cross section, and this is a ring shaped element, soil element that was considered. So water is coming out and going out, coming in and going out. Okay, discharge, inward discharge, and outward discharge from this ring shaped element. And through this, this is the differential equation which was expanded to develop this matrix equation. And using this matrix equation, by double integration, we solve the problem. So this is the stress concentration ratio. What is stress concentration ratio? If you take a certain point on the column soil interface, the stress on the column and the stress on the soil, their ratio is termed as stress concentration ratio. So it is always greater than 1, and for in case of a typical column and a typical soft clay soil, it varies usually from 2 to 5 as per the existing literature. So these are the expressions for the same, the stress concentration ratio, which we derived using analytical modeling. And next comes the column lateral deformation. Okay, so whenever a stone column is subjected to vertical compressive load due to elastic deformation, elastoplastic deformation, from Timoshenko theory, we derive this expression. Next comes the Brailling effect. What is Brailling effect? For example, if you take a metal cylinder and if you test under compressive load in the laboratory, due to frictional stress, friction of platen on the top surface and bottom surface, the deformation, lateral deformation on top and bottom surface is minimum or negligibly small, and the deformation is gradually reduced. So after compression, this cylinder will take a barrel shape. So the same thing holds good for the column, stone column as well, and sum total of these two, okay, gives the net lateral deformation. This is the mathematical expression below for the Brailling effect, and third one is the net lateral deformation. Right. Without going further into details, let us proceed to the next slide. This is the load bearing capacity. Okay, this is the stress on the column, stresses on the soil, non-uniform, stone column and the soil. So these are the mathematical expressions for load bearing capacity. Right. So this is the numerical simulations which we adopted you see the space time has been discretized depth wise, radial wise, and time wise into a number of elements. And this last figure is a two-dimensional view of the numerical discretization carried out on radial indices and time indices. Okay. So this was the computer program, the flowchart of the computer program that was developed using a supercomputer, the computational facility of University of Wollongong. We developed this computer program. So these are some of the results, right? So we compared the numerical results obtained from the mathematics, from the field test results and the laboratory test results, and also the solutions from the previous theoretical solutions, and we find that our computer program is working fine. So these are some improvement and settlement factors. So improvement factor is nothing but a ratio of the strength of soil after the consolidation and strength of soil before the consolidation. Similarly, the settlement factor is ratio of settlement after the stone column insertion and without the stone column. So this ratio. So as you can see, it is a function of time and imposed load intensity. And the settlement factor is a function of the spacing and the depth of penetration. I don't want to go further details. So this load bearing capacity has been derived. So we find that this load bearing capacity gradually increase with the time. As the time is increased, the load bearing capacity gradually increased and asymptotically stabilized to a constant value, right? And whenever the spacing of the stone column is increased, the stone columns are spaced far apart, okay? Then also the bearing capacity gradually is reduced non-uniformly. Next comes the influence of cyclic loading. Let us take an example. This is a typical railway track. A train is moving on the railway track. So whenever the train is moving, so this is a typical load versus time plot. You can see it approximately is cyclic pattern, but there is a zigzag pattern as well. Okay, so we have regularized this pattern into a purely sinusoidal pattern having a definite equation. Okay, and doing some mathematical derivations, we found that the yield surface contraction takes place, because of which the gradual progression of the soft soil bearing capacity reduction takes place. So these are the results from cyclic loading. As you can see, whenever the number of cycles is increased, the pore water pressure is gradually increased. So this can be visualized more prominently in the next figure. We increase the number of cycles, the pore water pressure is increasing. This is the frequency, cyclic stress level, and initial consolidation ratio. Okay, these parameters were studied. So we validated the lateral deformation with the field studies. We see that our computer gives good result. Next comes the model study. So in this laboratory, this is a schematic view, and there is a mold which is filled of confining chamber, which were filled with soft clay, and we install one stone column through replacement method, and there are a number of pore pressure transducers and linearly variable differential transducers in the equipment, and the air pressure was applied on the soil surface by means of air pressure, okay, gradually applied. And you can see the second figure is the deformed unit cell, and the third figure is the exhumed column, okay, the column which was exhumed after the completion of experiment, right? So this is the top surface view. The first figure is the top surface view. The outer is the soft clay and the inner is the stone column, stone particles or the stone aggregates. So we inserted a pair of strips. So you can see the strips here. These are fitted with electronic strain gauges. We inserted into the soil, right? And this is basically a measured and predicted low settlement response. You can see the applied pressure was stepwise increased by means of air pressure compressor, right? And this is it is matching well with the time versus settlement, okay? and the measured and predicted responses, they are matching well. Also, we carried out interface characteristics, that is the interface between the soil and the stone particles. What will be the interface? So if you can see, if you take one small element here, you can see the stress level, which you can see here in the next graph. Okay, and this is the photographic view at the bottom, and you can see this is the variation which we found from experiment. In the last figure, we see that the numerical results are closely matching with the experimental results. So this is CNS shear box. What is CNS? It is constant normal stiffness. So whenever we impart load, vertical load, there will be a constant normal stiffness will be imparted on the shear box. So intrusion of fines, that is clogging, and the lateral deformation, which is bulging, right? So they occur simultaneously in real life. So whenever the reinforced soft clay surface is subjected to some vertical stress, so this is the stress on the column and this is the non-uniform stress on the soil. So because of the higher magnitude of stresses, bulging takes place, that is the lateral deformation on the upper portion of the column, that is bulging, and also intrusion of fine takes place, and both the bulging and the intrusion of files, that is the clogging, they occur simultaneously. Okay, and this is a completely clogged column, and this is not acting currently, this is not acting as a drain because it is completely clogged, and this is an undesirable situation. So the engineer's design objective should be make the life of the transport infrastructure in such a way that before completion of the life of the structure, the clogging does not take place fully. Okay. So the intrusion of fines or the clogging were tested in the laboratory by us through CT scan. You know, CT scan in medical patients do CT scan in hospitals. So we did the same thing in our laboratory. Okay, because we have a medical department as well in our university. So we did some CT scan of the soil sample and the stone column. So you see the first CT scan X-ray plate. This is the column is not clogged yet, and the second figure, the column has been clogged. You can see the white patches near the circumference of the column. This is a partially clogged column. Okay, so this graph below, time versus the clogging parameters. The clogging takes place gradually. Okay, so the radius is gradually decreases. Okay, because you see in the second plate of the X-ray, the inner core, which is black in color, they are all still capable of drainage, and the outer white circumferential clogged zone, they are not capable of water drainage. Okay, so it is gradually, the effective radius of drainage is gradually reducing. Okay, and we compared our results, our lab results with the field results, and excellent matching was found. And we also did some lateral deformation bulging observations, and don't want to go to the details. As you can see, the last graph, so the points are the experimental values and the graphs are the computer generated values. So they are all matching. So this is what the time versus the lateral deformation for the experimental and numerical results. Okay. So we also found out the permeability of clogged column zone through X-ray diffraction test like this. This is the vertical cross section. Okay, this is the vertical cross section and this is the horizontal cross section, and we found out the permeability. Okay, next comes the field-based investigation. Okay, so it was done at Ballina. Okay, you can see the map here. This is Ballina is somewhat situated in the eastern coast of Australia, and our university was situated somewhere here, south of it, 300 kilometers south, University of Wollongong. And if you go 300 kilometers upward in the north, there is a coastal zone, Ballina, where we carried out this test. It was done by the Government of Australia, the National Soft Soil Testing Facility at New South Wales, Australia, and it was supported by Australian Research Council, Centre of Excellence for Geotechnical Science and Engineering, okay, CGSE. So on this side, you can see the Balina aerial view taken from the plane. This is the aerial view. Okay. So at this site, Keller Ground Engineering. Keller Ground Engineering is a multinational company situated in almost all countries, all leading countries around the world. So their headquarter is in Australia, not headquarter, a major office is in Australia. So they install a group of stone columns. Okay, you can see the side view, plan view of the stone columns. 50 stone columns were installed in 3 diameters. So the left hand side has 100 millimeter diameter, 1 meter diameter. Second phase is, second group is 0.8 meter diameter, and the third group is 1.2 meter diameter. So 3 group of stone columns were installed at the site. So you can see the photography of the installed stone columns here at the last figure. So this is the site location. You can see the map of Australia, and below the southeastern part, there is the New South Wales state is there. Okay, this is the enlarged portion of the New South Wales state. So there was the university here, somewhere here, our university of Wollongong. 300 kilometer upward is the Balina. You can see the arrow figure. This was the site, and the last figure is the photography of the site location, right? So this is what we carried out. So first we excavated the subsurface and export the stone columns and located the stone columns. Then we installed the inclinometers at the stone columns. Why we install the inclinometers? In order to measure the lateral deformation of the stone columns, we install the inclinometers. Next, we installed the piezometers. Why the piezometers were installed? The piezometer were installed basically to measure the developed excess pore water pressure under imposed loading. Next is the extensometer, which was installed underground due to measure the vertical deformation at different soil layers. After that, we installed the pressure cells and stone column and the settlement plates. Okay, so the left hand side is the settlement plate. As you can see, it is nothing but a square steel plate with a vertical rod. So it was just installed on the surface of the soft clay, and the right hand side figure are a group of plate pressure cells. They are installed on the surface. So the settlement plates measure the settlements by means of survey method, maybe geodetic survey method, okay, theodolite survey or GPS survey. They can measure the settlements. The pressure cells can measure the pressures. So all these inclinometers, the piezometers, the extensometers and piezometers, they are connected by underground cables through a data logger. Okay, this is a last figure is of data logger, and this is a, you can see the underground cable here, the white cable. So all the wires from the different instruments through the wires, they were connected to the data logger. Okay, so through the data logger from our university, we can remotely access the data logger data whenever we require. Okay, because this data logger had a battery and they operate all the time, right? So that was the arrangement that was made. So this is a plan view of the complete instrumentations. After completion of instrumentation, you can see majority of the instrumentation were centered around the central column. Okay, near the central column, most of the instruments. Okay, and on the finished and instrumented soil surface, we constructed a square embankment. The bottom surface of the embankment was 15 meter by 15 meter base area, and the top surface was 6 meter by 6 meter base area, right? And the side slope of the embankment is 1.5 meter horizontal to 1 meter vertical, 1.5 horizontal to 1 vertical. That was the side slope. Okay, and the data logger was situated somewhere in the near the western part of this site. Okay, and there was a small lane, small roadway here, a flathead lane where some traffic moves. Okay, you can also have lots of lanes in front of your houses. So this was flathead lane. So this was the north location, as you can see. So you can see the photography of some of the instruments, inclinometers, extensometers, the piezometers, and the stone columns. Okay, and we lay one geotextile cover for safety on the instrumented soil surface. Right. So before construction of the embankment, we did some piezo cone test, okay, or the cone penetration test. So why did we perform the piezo cone test? In order to assess what is the characteristics, strength and stiffness characteristics of the in situ soil. In order to assess this, we carried out the piezo cone test at the site. You can see the photographic view here. And this track is of Center of Excellence for Geotechnical Science and Engineering, which was funded by Government of Australia. So these are some of the raw data of the piezo cone test obtained directly from the computer fitted with the truck. And these are the process data. You can see how the, with depth, how the density, the moisture content, the consolidation characteristics, and the undrained strength of the soil increases. So you can see here the top 10 meter of the soil is soft silty clay soil. And below this, it is stiffer medium silty clay soil, right? Anyway, so this was the proposed embankment, and we initially carried out some computer computations, what will be the approximate settlement after 3 months or 6 months, like that, okay? So this construction in progress. So initially, we filled up with ballast, you see railway ballast. So that type of ballast, we filled up the site. After that, safety geotextile cover. And after that, this is the, we did some theodolite survey and we located the embankment on the ground surface. Okay, you see the base and this is the top. Okay, after that, we started constructing the embankment. You can see the embankment construction in progress. So it is partially constructed and now it is fully constructed. Okay, you can see here the third figure, fully constructed embankment. And the last figure, you can see my car here in the left hand side. There is a car, it was my car. And this was the data logger. Okay. So this was the engineering view, engineering drawing of the site. And this was a phase-wise load is imparted, time versus imposed load intensity. The load was imparted phase-wise on the soil surface. And these are the measured versus computed ground settlement. So the measured settlement was measured by GPS survey by the settlement place. These were the measured values. And this is the computed value. They are matching well, right? Next one is the lateral deformation, which we obtained from the inclinometer readings. So these are the readings obtained, right? So this is the stress concentration ratio, that is the stresses on the column divided by the stresses on the soil, right? Which we obtained from the pressure cell readings. And we can see the red graph on the top, the radar plot, it is the field observation, and the below graph, the bottom graph is the computer generated of results. So they are matching well, correct? Next comes the conclusion. What is the conclusion? First conclusion is that the stone column reinforced soft ground bears greater load due to higher stiffness as well as accelerates the radial consolidation. So this is the bottom line of conclusion, right? The second conclusion is that the load settlement and consolidation characteristics is significantly affected by the particle morphology, the arching, clogging, and smear effects. Okay. This is also very important conclusion. And the last conclusion is that the stone columns effectively dissipates the excess cyclic pore water pressure depending upon the column soil relative stiffness and the cyclic loading parameters, that is the number of cycles, the frequency, and the amplitude. This is very most important conclusion so far as the transport infrastructure is concerned. Okay. So after that, so this concludes my presentation. We did a number of publications. We are still publishing, but these are 5 major publications that are made, 5 journal publications in topmost international journals, and 4 major conference publications. And I should acknowledge the financial support that I received from Australian Research Council, the industrial partners, the Coffee Geotechnics and Killer Ground Engineering, University of Wollongong, the Ballina Soft Soil Testing Facility, okay, because the local municipality helped us to carry out this field study. Next, Professor Buddhima Indoratna, Distinguished Professor of University of Wollongong. Professor John Carter, Deputy Vice Chancellor, University of Newcastle, and my PhD students, Furman Seahan and Taipei, and my ME students, master students, Mr. Samir Bharadwaj. All of them contributed significantly to timely completion and successfully complete this research project. So thank you very much. So if you have any questions, I think you have many, so I shall be happy to answer some of them, right? Depending upon the time constraints. So thank you very much.
Thank you so much, sir, for your really interesting and wonderful presentation. Now, I would like to request the audience, if you have any question. Actually, today we have 10 minutes time in hand. So if you have any question, please ask.
Yes, sir.
Or you may raise your hand.
Yes. Yes, sir. Good morning, sir, and good morning, everyone. I'm Niranjan Pal from Civil Engineer. Sir, thank you very much. First of all, thank you very much, sir. Today we learned such a beautiful or such a technical person from you, sir. First of all, thank you very much, and I am very lucky to hear such a beautiful topic. Sir, I have 3 small questions. Question number 1, sir. This reinforcement, stone reinforcement is a deep foundation or shallow foundation, sir?
Stone column reinforcement. Yes, I got your question.
Yes, sir.
Right. So the stone column reinforcement is naturally. I think there's some echo, right?
Niranjan, please mute yourself.
Right. So basically, the stone column reinforcement is imparted on a shallower deposit. Whenever it depends upon whether it is shallow foundation or deep foundation, it is not foundation, right? It is a technique for improving the soft ground. Okay, there are various techniques. For example, if you impart some chemical materials, some admixtures on the soft ground, okay, because of chemical reactions, the strength and stiffness of the soft soil gets improved. That is a chemical stabilization. Here, in case of stone columns, so it is a granular reinforcement. By means of reinforcement, you are improving the strength and stiffness of the soil, right? So above the reinforced soft soil, you can construct a foundation, okay? So for example, on the stone column reinforced soft soil, you want to build up your own house. You are a civil engineer, you should have your own house. So if you want to build up your own house, okay, you have to design and construct a foundation on this reinforced surface, because now the soil is strong enough to withstand the foundation. So you can go for shallow foundation, okay, which is most preferable. And someone for heavy structure, someone can go for pile foundation. For example, a runway. So Dum Dum Airport, you know Dum Dum Airport, it has a soft clay soil. Normal Calcutta soil is soft clay soil, and the heavy planes, okay, we have A380 planes, which is heaviest plane, and whenever the plane lands, okay, a higher amount of dynamic loading is imparted on the runway, which goes below the soil. So in those cases, I think pile foundation is adopted, even if we improve the soil by granular reinforcement. I think you have got your question. Thank you very much. It was a very nice question.
Yes, I think Niranjan has more questions. Niranjan, would you like to ask any more question? You started with number 1, number 2 like this. So that's why I asked.
Yes, ma'am. I have another question.
Okay.
Question number
Please.
2 is, ma'am,
Please.
sir, like pile foundation, you have a different type of boring process. In stone columns, in stone column reinforcement, what type of boring process is there, sir?
Yes, this is a very important question. Right. So installation of the stone columns. Okay. So the method of installation may be you see that we have done something laboratory tests. So the method of installation was replacement. What we did is a hollow cylinder we inserted inside the soft soil, which we poured the stone columns, and we withdraw the hollow cylinder. Okay, that is called replacement method. So we replace the soft clay by means of stone column. This is a replacement method, but that is not possible in the field. So in the field we install a mandrel. Okay, and through the mandrel we initially apply some water jet. Okay, we install some water jet in order to make the surrounding soil softer. After that, we install the stone columns by means of stone aggregates are inserted into the mandrel, and gradually the mandrel is vibrated and withdrawn. Okay, because in this way the surrounding soil gets densified. So that is the wet method. And sometimes in case of whenever the soft clay deposit is of shallower depth, so in that case the water jet is not required. That is called dry method. So basically these are the methods of installation. Okay. Thank you.
Any more question from the audience? Any other question? You may please raise your hand. Yes, Shubhankar. I would request the web host, please.
I have Ma'am,
Hello.
I have one more question.
Hello.
Can I ask?
Yeah, Shubhankar, please.
Yeah. Hello. Good morning, everyone. Good morning, sir. Good morning, sir. I have a question that has this process has been implemented anywhere else, or is it in the experimental process right now?
Which method? This stone column?
This stone column process, has it been implemented anywhere in our Kolkata or somewhere else in India?
Yes. So I think, let me ask you a simple question. Have you ever visited Taj Mahal?
No, sir, not yet, but I would love to visit.
Many of us have visited, including me.
Yeah.
And Taj Mahal is very old structure, as we know, all know, right? So 2000 years back. So this Taj Mahal was constructed on the stone columns, because in Agra, at that site, it was a soft clay site, and stone columns was inserted, and it was built like that. So Taj Mahal, I think it is one of the oldest structures which was built on stone columns. Okay, and there are many structures, and it is a standard method of ground improvement, I should say. Let me continue. So it is a standard method of ground improvement, the stone columns. Okay, but the problem is that we don't know the engineering and scientific theories, how it works, and what are the problems, and what are the solutions. How can we design? These answers we don't know. So whenever we adopt this technique in the field, so in that case, we use our past experience. The design engineer or the construction engineer, they take their past experience to make the construction. So that is not desirable. So in order to gain insightfulness, so we carried out this research to find out what is the scientific theory behind this phenomenon, right? So that is the thing.
Sir. Yeah. Okay, understood. And one more thing, sir, is it cost effective than the pile foundation?
Yes, definitely. Actually, we should say that in case of pile foundation, there is a lot, as I was saying, that there is a lot of carbon emission, because this pile has to be manufactured at the construction site, okay, or the yard, construction yard. It has to be manufactured, and then they have to be driven inside the soft clay deposit. So there is a lot of environmental pollution. So, but in case of stone columns, there is no such pollution. And also, the stone columns assist in taking out the water, drainage of water from the soft clay, as a result of which the soft clay itself becomes strong. But in case of pile foundation, the soft clay is not tendent, right? So that is a difficulty.
Sure, sir.
And also at the same time, due to manufacturing cost and driven piles driving cost, the cost is much more, little more in case of pile foundation. Right.
Okay, sir. Okay. Thank you very much, sir. Yeah. Thank you
Sir,
for the-
I think we can take one more question. This is the last question. Niranjan actually wanted to ask something. Niranjan, please.
Thank you, ma'am. Thank you, sir. Another question. I have another question. It is when we'll do the pile foundation, we make
Right.
on the NGL
Right.
or GL pile cap. When we'll do
Right,
the
pile cap.
it's required pile.
Right, pile cap.
Yes, sir. We do the pile cap before start superstructure. On stone reinforcement, it's required pile cap or not? It's required cap, any type of cap or not, sir?
Okay, I got your question. Okay, I got your question.
Yes,
Very
sir.
good question.
Thank you, sir.
Yes, we are again
Yes,
echoing. Right. Right. Okay, let me explain this like this. So stone column in apart from pile foundation is a foundation, is a type of foundation, right? But the stone column is not a type of foundation. It is a technique of improving the stone column, improving the soft clay. Okay, improving the clay, right? So, for example, many of you are student here. You will undergo the BTech course. After completion of the course, you will gain knowledge. Okay, we are inputting knowledge. So your own performance will be improved. In the same way, whenever we install stone columns on the soft clay deposit, the soft clay itself will be strong enough. Okay, and we can adopt the foundation. We can design and construct the foundation as per requirement. Okay, so in case of pile foundation, definitely we need the pile cap. For stability point of view, we need a pile cap. But for stone columns, nothing such is required. But if you want to adopt shallow foundation or pile wrap foundation, definitely we need a raft or a footing, right? So that depends entirely upon the foundation concerned.
Thank you very much, sir.
Right. Thank you.
I learned
Thank
today. I learned very interesting technical things from you, sir. I am very lucky person. Thank you very much, sir.
Thank you, sir. We are really grateful that patiently you have answered all those questions from the students. Thank you once again. Okay. Sir, please accept a little token of appreciation from Elite College of Engineering and specifically from the Committee of DEEP 2022. Please allow me some moments.
Thank you very much. Thank you, moderator. I accept this.
Yes, sir. Yes, sir. The certificate of appreciation is visible to you?
Yes, it is visible to me and I accept this.
Okay, sir. Thank you so much. Thank you once again for your wonderful presentation. And moving on, I'll be going to the next segment. I'll be going to the next segment, that is contributory paper presentation. I think I'm clearly audible and visible. Gautam sir, am I clearly audible and visible?
Yes, ma'am. Yes, ma'am.
Okay. So going to the next segment of this technical session, that is the contributory paper presentation on the subtheme civil engineering. And the first presentation, that is the student paper. It's it is quite an interesting paper. What I can see, that is based basically on Elite College of Engineering. The research work has been done on Elite College of Engineering. The paper's name is Provision and Scope of Rainwater Harvesting at Elite College of Engineering, authored by Shormishta Datta, Maupriya Basak, Fiza Yasmin, Shushmita Haldar, and Rishika Mukherjee. I think Shushmita Haldar will be the presenter, and the session chair of this specific session is Professor Dr. Krishna Hajra, and the session judges are Professor Abhijit Karmakar and Professor Dr. Ashwini Kumar Sharma. I think all of them have joined. They are already with us. So I would request Shushmita to please start the presentation. But before that, I must remind her that your time limit is 10 minutes. And just in the 9th minute, I will give you a reminder and you have to complete within 1 minute. Okay? So please start.
Ma'am, I am audible?
Yes, Shushmita, you are audible.
Ma'am, 1 minute just.
Yes, yes, please.
Ma'am, screen share already?
No, I cannot see your screen. Shushmita, if you cannot, we can play the PPT for you. We
Yes,
have
ma'am.
your
Yes,
PPT.
ma'am. Yes, ma'am.
Okay. Gautam sir, would you like to play the PPT? Yes, your PPT is visible. Please start.
Thank you, ma'am. Good afternoon, all the delegates present. We got the opportunities to represent at college. Our group member Mopriya Bosak, Shormishta Dotto, and Fiza Yasmin, guided by Rishika Mukherjee, Assistant Professor of Civil Department of ECE. Our presentation name Provision and Scope of Rainwater Harvesting at ECE. As the population increases, the demand increases for quality drinking water. India is facing the worst water crisis in its history, and 21 Indian cities, including Delhi, Mumbai, Kolkata, will run out of groundwater by 2021, affecting 100 million people. 40% of India population will have no for surface water uses instead of going for groundwater resources. To meet human demand or needs, consider the main source of surface water rainfall is deemed more or less as fresh. Therefore, water saving becomes a necessity. So, we know that what is rainwater harvesting. Rainwater harvesting is the collection and storage of rain rather than allowing it to run off. Rainwater is collected from a roof-like surface and redirected to a tank. Deep pit shaft or also be collected with nets or other tools. Its uses include watering gardens, livestock, irrigation, domestic use with proper treatment, and domestic heating. The harvest water can also be committed to longer term storage. Rainwater harvesting is one of the simplest and oldest method of self-supply of water for household and residential and household scale project usually financed by the user. Large system for school, hospital, and other facilities can run off cost only able to be financed by companies, organization, and governmental units. So we are know that method of rainwater harvesting. Three types of method: surface runoff harvesting and rooftop rainwater harvesting. Surface runoff harvesting know that In urban area, rainwater flows away as surface runoff. This runoff can be caught and used for recharging aquifers by appropriate method. Rooftop rainwater harvesting. It is a system of catching rainwater where it falls. In rooftop harvesting, the roof becomes the catchment and the rainwater is collected from the roof of the building. It can either be stored in a tank or diverted to an artificial research system. This method is less expensive and very useful if implemented correctly. Groundwater level of the area. Component of the rooftop rainwater harvesting. Catchment area, transportation, and fast flush. Catchment area, the surface that receives rainfall directly, is the catchment of rainwater harvesting system. It may be terrace, courtyard, or paved or unpaved open ground. The terrace may be a flat RCC or stone roof or sloping roof. Therefore, the catchment is the area contributes rainwater to the harvesting system. Transportation, rainwater from the rooftop should be carried through down to take water pipes or drains to the storage harvesting system. Water pipes should be UV resistant. Fast flush. The fast flush is a device used to flush off the water received in the fast shower. The fast shower of rains needs to be flushed off to avoid contaminating storable, rechargeable water by the pourable contaminants of the atmosphere and the catchment roof. It will also help in cleaning of silt and other material deposited on the roof during dry season. Provision of fast rain separators should be made at the outlet of each drain pipe. Filter. There is always some skepticism regarding rooftop rainwater. Since doubts are raised that rainwater may contaminate groundwater, there is a remote possibility of this fear coming true if the proper filter mechanism is not adapted. Secondly, all care must be taken to see the groundwater sewer drains are not punctured and no leakage is taking place in close vicinity. Filters are used for the treatment of water to effectively remove turbidity should pass through filters. There are different types of filter. Basic function in purify water, they are as follows: sand gravel filter, charcoal filter, PVC pipe filter, and sponge filter. So let's know advantage of rainwater harvesting. Less cost, helps in reducing the water bill, decreases the demand for water, reduces the need for imported water, promotes both water and energy conservation, improves the quality and quantity of groundwater, does not require a filtration system for landscape irrigation. This technology is relatively simply easy to install and operate. It is an excellent source water for landscape irrigation with no chemicals and dissolved salts and free from all minerals. Our college, our elite college, B block, climate in location. The annual temperature is about 27 degrees Celsius. Monthly mean temperature ranges from 19 degrees Celsius to 30 degrees Celsius. Agarpara is dominated by the three seasons, namely summer, monsoon, and winter. The summer is hot and humid with mean temperature about 30 degrees Celsius. But during dry spells, the maximum temperatures often exceeds 40 degrees Celsius during April, May, with a frequent break by sharp thunderstorm, thunder squall, and during afternoon or evening hours.
Sushmita, last minute.
Yes, ma'am.
1 minute left.
Yes, ma'am. Disadvantage of rainwater harvesting. A regular maintenance is required. Disadvantage of rainwater harvesting. Regular maintenance is required. Requires some technical skill for installation. It is not installed correctly, it may attract mosquitoes and other waterborne diseases. One of the significant drawbacks of the rainwater harvesting system is storage limited. Our conclusion, rainwater harvesting is usually taken to mean the immediate collection of rainwater running off surfaces upon fallen directly. So collecting rainwater is cost effective and the best alternative to the scarcity for water worldwide. Therefore, rainwater harvesting should be improved to gain sustainability in various aspects in rural as well as in urban areas. Last of all, I would like to thank my honorable teachers right by our presentation. So thanks to all everyone.
Thank you so much. I would like to ask the audience if you have any question. I won't be able to take many questions, but 1 or 2 questions I can take. Please raise your hand.
Yeah, ma'am,
Okay,
I have a question.
Shubhayu. Yes. Oh, sir. Yes, sir. Sir, please.
Yeah. Ma'am, my question is that the areas where rain is already there, if you talk about east, northeast, and south, these are the areas which are rich of rain. But there are areas like west and north which are not as rich as rain. So, do we have any data that how much rain harvesting thing has contributed to take up the water table? Just a simple answer. Just simple answer. Okay.
Yes, sir. Our presentation, my presentation.
Okay. Gautam, sir, please play the presentation once again.
Susmita, Madam Susmita,
Yes,
you
sir,
can
yes,
just
sir.
answer that question. Just answer. Don't go for the PPT.
Sir, rainfall West Bengal 1625 millimeter per year.
Okay. So, do we need rainwater harvesting there in West Bengal?
Sir,
Hello.
repeat question.
No, I am asking, do we need rainwater harvesting in West Bengal? Where it is
No, sir.
already rich with the rain.
No, sir. We don't. We
Yes,
do not have the date
right.
where rainfall is very scarce, like in Rajasthan.
Yes, right.
Thank you,
So
sir.
my thing is further you can start studying how rainwater harvesting can be advantageous in north side areas where they are deprived of rain. That's it. Okay.
Yes, sir. Yes,
Thank
sir.
you.
Thank you, sir.
Okay, thank you, Shushmita.
Thank you,
I'll be
ma'am.
going to the next speaker. I think the next paper is again another student paper. The title of the paper is Membrane-Based ultrafiltration of toxic effluent to combat groundwater crisis. And the authors are Pralay Kumar Ghosh, Shubhodip Saha, and Dr. Biman Goti Gupta. I would request Pralay, I think you are already present right here on this platform.
Yes, ma'am.
And please maintain that time. Okay. In the 9th minute, I will just give you a reminder. Okay. Please start.
Ma'am, Mohua ma'am.
Yes.
Ma'am, I can't mute my microphone.
Okay. The web host Jeet sir, please. Okay. You are already muted. Pralay, please start.
Hello. Okay. So, ma'am, it is audible and visible?
You are audible, but slide is not yet visible.
Yes.
Yes, visible.
Ma'am, slide now visible?
Yes, please start.
Okay. Good afternoon, all of you, respected dignitaries and all chief guests and organizing committee. Our director, sir, Dr. Bojrul Haq and Mr. Sajol Ghosh, and our respected principal, sir, Dr. S. Bosak, and student or faculties, those who are presenting National Conference DEEP 2022. Our article, Membrane-Based Ultrafiltration of Toxic Effluent to Combat Groundwater Crisis. Research and presenting by myself, Mr. Pralay Kumar Ghosh, final year student of Elite College of Engineering 2020, and the head of the Department of Civil Engineering, Dr. Biman Goti Gupta, and the student Shubhodip Saha, final year student of 2020. The objective, assessment the nature of effluent generated for textile bleaching and dyeing unit. The Kalikapur area, which is situated Mohestola region in South Chobbish Pargona, West Bengal, India. Provide a sustainable management of underground water resource through installing CPTS with zero liquid discharge system. That is the objective of our article. Next, we take different kind of unit. It's maybe a large unit, maybe a small unit, it's a big unit. The total discharge wastewater estimated 2000 MLD. We studied the 50 units the year of 2060 to 2090. Location, the near about Kalikapur area. Next, here we see the different kind of chemical variable like HP9, POD 6 to 8 milligram per liter, COD 1924 milligram per liter, and TDS 6510 milligram per liter, and last but not the least, TSS 936 milligram per liter. And next, metal of wastewater, lead 0.44 milligram per liter, and chromium 0.032 milligram per liter. Also, the zinc 0.75 milligram per liter, and also the nickel 0.07 milligram per liter, and cadmium 0.03 milligram per liter. Next, the result. All other result are exceed. The standard permissible value, the standard permissible limit are exceed. Stipulated by FAO 1985 and World Health Organization 2003. Next, the effect of ecology and health. That is very important and very vital effect. wastewater create a effect our ecology and our health. Environment also the human being's life. So the next, the effect of ecology. We know the crops, vegetable, and also the architecture and also the agricultural land, also groundwater affected by wastewater. That is very harmful our nature. So need to do something to resist that kind of effect. We go to the next slide. Now the solution. What is the solution to stop that kind of problem? Immediately need 4 to 5 CPTs urgently need to install at the different location of Mahestala Kalikapur region, which is need to 50 MLD capacity each in the area of Kalikapur area. That is the solution to resist that kind of problem. And the manage of large volume wastewater like 2000 MLD. That is the sustainable management of underground water resources, where the situated the thin mass density urban area near the Calcutta region. So here the figure we saw, the location of Mahestula region, South Chobbish Pargana, which is situated in West Bengal, near the Hooghly River, and another side the Calcutta Khidirpur, where present the research, where we organize the research. Next we go the figure, that is here have a different kind of data, wastewater quality details through the table format. Need to temperature. Here we show the three parameter wastewater and the drinking water, also the groundwater. The different thing is the temperature, the wastewater 30, the drinking 25, and the groundwater 10 to 32.5. And one by one we saw TDS, TSS, BOD, COD, lead, the difference between three columns. So we go to the next slide. Wastewater canal we saw, which is situated in Mahestala region, the wastewater canal. That is the important part of our presentation of our article, the flow diagram. Total project we divide the two parts. First part the primary or solid particle separation. Second is the secondary or chemical particle separation. First, we collect the total water 1A and 1B, that is the equalization tank, and after that the 2A, 2B, that is the plus mixer. Plus mixer, we added the start such kind of chemicalization. We added the alum for the help of chemicalization, and after complete the 2A and 2B, the next is 3A and 3B. Califoculator the 3A and 3B, and then the 4A and 4B, 4A and 4B aeration tank, then the 5A and 5B secondary califoculator, then 6A, 6B, 6A, 6B sludge thinker, 7A, 7B filter press, the 8A and 8B also the sludge storage tank. We saw here 4A and 4B, that is the baffle wall, where we passing water with low velocity, the dissolved solid particle easily settle down in lower portion. That is our first part, that is our primary part of our presentation of our project. And now we go the second portion, that is very important, that is the membrane based ultrafiltration and river osmosis. After completing the first part, we collect the water in tank and we start the second part through use of two kind of pumps. One is a UV feed pump, another is RO high pressure pump. Use of UV feed pump, water through the strainer, and after completing the strainer process, then water through passing the ultrafiltration.
Pralay, last minute.
Ultrafiltration and river osmosis. After complete the river osmosis, then the complete the total process. Here have all the data that is designed by Indian Standard Code. That is very important. We can't design without follow Indian Standard Code. The performance rate, the performance parameter here, pH value, VOD, COD, everything is the performance. The difference between before test, before processing the our process, and after complete the process, the difference of that kind of value. Also here we saw the different size, the ultrafiltration and filtration 3.0 and the 3.30, and the life of 4 to 5 years, here the life of 3 to 5 years, and also the number 3, here number the 8. Here also the discharge recovery 90 to 95%, here the 75%, and the rejected 5 to 10%, here the 95 to 98. The discussion is the important another part, where the complete discussion Indian present their report global goods present industrial wastewater treatment. The value and our value both are similarly same. So we continuing our process. It is helpful for us. That is the canal flow wastewater which is situated in the moist-tular region, and the pollution length in moist-tular region, that is very harmful, and at the end lost, and the end the conclusion CPD plan actually the wastewater resource the 55%, 11 KD total wastewater of 2000 KLD. Actually our project, the main motto, resist the 3 kind of problem. First, water pollution. Second, soil pollution. Third, the groundwater. If we use the water through the recycle process, continue this process, need to stop use the groundwater. If we continue certain time, the groundwater easily increase. Now we face all of you groundwater after day to day decrease. If we continue in this process, after certain time, we can relieve the groundwater easily increase. That is the conclusion of our project. That is the conclusion of our article. If we benefited by use that kind of problem, by use that kind of process, that is the conclusion of our article. Thank you very much.
Thank you, Pralay, for your wonderful presentation. I would like to request audience, if you have any question, you may please raise your hand. Only one question I'll be able to take. Any question from the audience? Okay, I'm going to the next session.
Thank you, ma'am.
Yes, and the speaker of this session, or the author of this paper, is Krita Goswami and Dr. Sudip Basak. And the title of the paper is a laboratory investigation on flow rates in saturated clay. I hope Professor Goswami is the presenter of this particular paper. I think Professor Goswami has already joined.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Sir, please
thank you, ma'am. Am I audible and visible?
Yes, absolutely.
Okay, ma'am. So thank you, Mahuya, ma'am. A very good afternoon to the respected session chair and judges and everyone attending this webinar. My name is Krita Goswami. I work at the Northeastern Regional Institute of Science and Technology in Arunachal Pradesh as a research associate in the Department of Civil Engineering. So formerly, I was working at the Scholars Institute of Technology and Management, Guwahati. So first and foremost, I would like to thank Professor Dr. Sudip Basak, sir, for giving me this opportunity to present our research. And I'd also like to thank the entire organizing team of this DEEP 2022 for their tremendous effort for smoothly running this webinar. The theme of today's presentation is a laboratory investigation on flow rates in saturated clay. So basically talking about this research, the manuscript is an attempt to determine the linear and non-linear flow characteristics in saturated clay. The saturated clay, the undisturbed soil sample, was taken from a depth of 1 meter in a nearby excavation pit on the Kaziranga University campus. That is in Assam. So Falling Head permeability test along with other tests discussed in the next slides were conducted on 3 sets and average values were considered. So I'll share the PPT now. Please let me know if it is visible. So is it visible, ma'am, the PPT?
Yes, sir, visible, but yes, full screen. Okay.
Okay, ma'am. Okay, ma'am. So, basically, like introduction, I have already given. The first slide I have already shared, discussed, and let's talk about the experiment. So, what experiments I have conducted to determine the flow characteristics? So the soil we have collected from Kaziranga University was low plasticity soil, and the test I have conducted was like specific gravity, Atterberg's limit, standard Proctor test, falling head permeability test, and later on we applied this Darcy-Forchheimer's equation, find out the Reynolds number to determine the flow characteristic. This was the main idea. This was the basic concept. So talking about the specific gravity, the ratio of the density of any substance to the density of some other substance taken as standard, water being the standard for liquids and solids, and hydrogen or air being the standard for gases. We have considered this distilled water as a standard. So in this experiment, we have conducted this experiment using this density bottle method. One more method is there, picnometer method, but we have opted for density bottle method. We have conducted this density bottle method, and on the sample which is passed through 4.75 mm sieve, and the specific gravity of the sample was determined to be 2.51, 2.61, and 2.55 respectively. The average of these three values is 2.56, which is considered throughout the research. And next, if I am talking about the Atterberg's limit, let me first tell you what is Atterberg's limit. So Atterberg's limits are the liquid limit, plastic limits, semi-solid limit. All these things are Atterberg's limit. So depending on water content, like a soil may appear in one of four states, which are the four states: solid, semi-solid, plastic, and liquid. So in each state, the consistency and behavior of a soil is different, and consequently, so are its engineering properties. Thus, the boundary between each state can be defined based on a change in the soil's behavior. So the Atterberg's limit can be used to distinguish between silt and clay, and to distinguish between types of silts and clays. The water content at which the soil changes from one state to the other are known as consistency limits or the Atterberg's limit. These are the one or the other thing. So there are three important Atterberg's limit. One is shrinkage limit, another one is plastic limit, and the third one is liquid limit. So, plastic limit and liquid limit I have shown in this PPT. The shrinkage limit is the water content at which the volume of the soil starts to increase. It is also at the point where the soil is 100% saturated. The plastic limit is when a thread of soil is rolled out on a non-porous surface and begins to crumble. When it reaches to a particular diameter, the liquid limit is when a specific width of groove in a sample contained in a standard pan closes up under the repeated dropping of that pan onto a hard rubber surface. We have this apparatus, Casagrande apparatus to be specific. So we used that and found out the liquid limit, plastic limit, and shrinkage limit. The liquid limit was found to be 24.8%. The plastic limit was found to be 16.5%, and shrinkage limit was found to be 6.5%. We have used IS 2720 part, part 5, I'm not sure. 2720 part 5, yes, part 5, which is in 1985. Then moving on to the next experiment, that is standard Proctor test. So a standard Proctor test is carried out to study or understand the soil's compaction characteristic with variable moisture content. The test is performed to estimate the maximum load of the soil could bear. hence ultimately reducing the voids present in the soil. The standard Proctor test is used in the study to assess the relation between the moisture content and dry density of soil sample. So maximum dry density is found to be 16.9 kilonewton per meter cube, and the optimum moisture content is found to be 7.2%. So what is dry density? Dry density is calculated by dividing the weight of the wet soil by its water content, and the optimum moisture content, we have this formula. So weight of water content with lead, considering it W1, weight of container with lead plus wet soil, considering it W2, weight of container with lead plus dry soil, considering it W3, then we can easily find out the moisture content. And IS 2720 part 7 of 1980 was used. Yes, correct. Moving on to the next experiment, falling head permeability test. So in the falling head method, the soil sample is first saturated under a specific head condition. The water is then allowed to flow through the soil without adding any water. So the pressure head declines as the water passes through the specimen. The advantage of the falling head method is that it can be used for both fine grain and coarse grain soil. We have another permeability test, that is constant head, that is specifically used for coarse grain soil. The falling head is used for both type of soil. So the values of the average velocity and hydraulic gradient like computed from the observed test data, and those are plotted as you can see in this figure. So for lower values of hydraulic gradient, the flow is expected to be linear, and the Darcy's law is applicable. Okay, Darcy's law is applicable, and the best fit line passes through the origin. How can I? No, I cannot show it. Okay, in the from 0 to, like you can see, the VCR point is there. Darcy's law is applicable, and for higher values of hydraulic gradient, on the other hand, Forsheimer's equation holds good, and the best fit curve is essentially parabolic with ascending slope. You can see above the Forsheimer flow, best fit parabolic is shown with an arrow. So from the figure shown in the slide, the point of intersection between the straight line and the parabola represents the critical point, corresponding critical values of velocity hydraulic gradient. So accordingly, VCR, that is critical velocity is 0.775 into 10 to the minus 4. It is in meter per second. And critical hydraulic gradient is found to be 0.64. Critical head is found to be 0.0813 meter.
Sir, last minute.
Yes, sir. Thank you. I'm just finishing it. The Reynolds number is the ratio. Later on, I have found out the Reynolds number. Reynolds number is the ratio of inertial forces to viscous forces within a fluid, which is subjected to relative internal movement due to different fluid velocities. The value of critical Reynolds number was evaluated as 1.11 into 10 to the power minus 2. So talking about the conclusion, the soil we have classified. The soil is classified as well-graded, low plasticity soil, and we have find out the critical velocity, critical hydraulic gradient, and critical head, and we have observed that for like low hydraulic head, the Darcy's law is applicable, and for higher this Forsheimer's flow is applicable. So that was the major conclusion we have done, and these are the references, and we have I have with the help of Professor Dr. Sudip Basak sir, we have published three to four papers relevant to this topic, and on different samples. Obviously, I have also done similar tests on sand and find out the characteristics. So this is all. Yes. So thank you, madam.
Thank you so much, sir. This is really an awesome presentation. I would like to ask audience, do you have any question? Anyone? Niranjan, okay. Please, Oebus, please. Okay.
Thank you, sir. Thank you very much, sir. I have two little questions. Question number one is, sir, For sand particles, it is easily shapes, easily defined from shape. You say the size of clay is 4.75 mm, but how it
Yes.
is, yes sir, how it is analyzed in sieve?
In sieve, sir, we have done the sieve analysis, and we have created this particle distribution curve.
Yes sir, because
Yes.
clay or plastic materials, it is all are saturated materials with liquid materials, with some materials are solid liquid, some materials are plastic. That's why it is difficult to analyze by sieve, no?
No, we have first the soil was oven dried, and then it was sieved. So there was no chance of having moisture in it during the particle distribution curve.
Okay sir, thank you. And second question is, uh, in India we'll do the work with IS code, Indian Standard Code, but
Yes.
when we do the work at overseas, like
Yes.
like other countries, Europe countries or Gulf countries, we follow the Indian standard or their standards?
No. We have this ASTDM, American standards. So that is followed.
Okay sir, thank you very much.
Yes. Thank you.
Okay. Thank you, Niranjan. Thank you, Professor Goswami, once again. I'll be going to the next presentation. That is again by one of our students, by Tanmoy Khatua. The presentation will be there on implementation of water science and technology. I think Tanmoy has already joined our platform. I request web host,
Yes.
please, Tanmoy. And here we have to play the PPT for Tanmoy. Gautam sir or Jeet sir, please help him. Please play the PPT on our end. It's not full screen. Yes. Okay. Please start.
Good afternoon, everyone. I am Tanmay Khatua, working as a project engineer in Wipro, and thank you for the whole Elite College of Engineering, all the department and also authority for choosing my paper for the conference. And my paper is implementation of water science and technology. So, water's another name is life because it is necessary to everyone in our whole universe. So why water is needed? Water is not simplest vital for human beings, plants and animals for maintaining life. It is necessary for everyone in the universe. And also, water is one of the considerable available substance in nature. Water forms about 75% of the problem on Earth's crust. And it is also regulates our body temperature, and it protects our tissues, spinal cord and joint. And there is also different type of solution. So that's why water is needed. Next slide, please. And next is, what is groundwater replacement? Groundwater replacement happens by directly recharge and inleaf recharge. Water hired for direct recharge extra regularly, that now not comes from the flow water conservation, recycles water, and also water transfer. And you also see that diagram side by groundwater. And at the some point also hydrological cycle, that is replacement happens evidently while rain, storm water glide from rivers, streams, creeks, filters into aquifer. We see the in the side picture. Next slide, please. Next slide is, what is water resource management? Water resource management is the action of planning, growing, and dispensing and dealing with the maximum beneficial situation use of water assist. It is miles a subset of water cycle management. And the main area of the wheel must preserve to residents to cutting edge and destination problems. And we can see the picture here is this, the how the water resource management is going on, because in the in rain, after the rain the water is coming into our soil and it also recycling. And also one of the maximum overage for our water primarily waste source within the future is sustainability of current and even destination waters. And also it is needed inside the environment that is also sustainability of water assist. Next slide, please. That is low cost water purification. And sometime due to the heavy cheap cost, we cannot purify the water, and some of the our rural area they drink the water uh, that is not suitable for their health, but they also drinking. So here is a low cost water purification. uh, in the low cost having many facility, we uh, see in this picture there is some rocks, quashed granite, charcoal, fine sand, cloth, so we can purify the water. And here is one of the most celebrities like Bill Gates, Matt Damon, and superstar to us, and also one of the Susan Davis. They help easy smooth clean rivers, dig wells, and installation pumps. And as we have indicated earlier, then many of us, 1.8 million humans, die each year from diarrhea blended to terrible water and sanitation. Most of them underneath age 5. So that's why we also use for the rural area low cost water purification. Next slide, please. The next slide is that is bone char filtration. And if due to heavy cost we cannot filtration, so here is we can filter the water using the animal bone. And you can see the pictures here, how the using the bone char we filter the water. And in location like rural area pollution leach into the water and stealing them is good concept. Persistent arsenic publicity in the rural area, for example, that's cause skin scare, bladder, kidney, lungs cancer, gangrene, and like diabetes, high blood sustains, and reproductive problems, etc. And also there is another most important problem, that is uranium with consumed water is linked into nephritis infections of the kidney. So due to this, many people are dies in the rural area, and some areas bone char may face cultural aversion to eating cow merchandise. And next slide, please. There is solar sterilization. So we can also filter the water using solar sterilization, and you can reference the picture how the water purify using the solar. And if the that is how can we purify in the clear bottles in the sun for some hours and UV radiation and worm kills the microbes that region diarrhea and particular waterborne infection. And also we using Swedish techniques that end up deployed in a few components of Haiti after the earthquake in 2010. And there is one of the also that is jerrycan like field with built-in thermal indicator that's purify the drinking water and also recognize while water is secure to drink. And also there is another, that is Sulphate box opens like book to water inside daylight so clean plastic panels. It is black backing allows it is take in extra daylight. That is all about the solar sterilization. And next slide, please. That is water conservation. And so I before said that water is important in our life, so that's why we need to conserve the water. So water conservation is the exercise of using water efficiency to reduce needless water uses. Consistent with fresh water water conservation is crucial due to fact clean smooth water is restricted resource. And we can say example one of the our country, that is India and United Kingdom's population has doubled during the last half of century, and our name for water has tripled. Water conservation is greater good size than ever, and sector is searching pointer on savings water. So that's why we need what we should everyone should we conserve the water. Next slide, please. So here is how to save water. And we can, if we want, we can save various way to save the water. So there is the difference technique. So there is a position brick in our bathrooms water tanks, and also use proper quantity of water for age load laundry. Select our washing systems wisely. Water flow accurately. So water flow accurately means we can use the water to flow the in our flowers gardens. That's why I say that water flow is we should use consistently, accurately, and set up a low watt sware head and check for and repair leaks. And last point is manage outdoor water use. Next slide, please. That is rainwater harvesting. Rainwater harvesting is the accumulation and garage of rainwater for use on internet website as an alternative permitting it to expire of, and also rainwater may accurate from rivers, roofs, and in many locations. And you can figure a reference, use the picture where we see that the rain comes and so it's mixed up with the soil, and with the soil we can also use the water. And it also makes us of embody water for gardens, cattle, irrigations, home use with the right remedy, and indoor heating for homes. And one of the rainwater harvesting is one of the smooth and ancient strategy for self-diver of water for household, typically financed by using patron. Next slide, please.
Last minute.
Okay. I will try finish. Next slide, please. And rainwater harvesting, that is advantage of rainwater harvesting. It offers water when drought takes place and can help mitigate flooding of low-lying region. And also it additionally enables within the availability of potable water, as rainwater is drastically freed from salinity and differences. And also rainwater harvesting is obligatory for brand new houses. Next slide, please. That is application of rainwater harvesting. We use different, we can use it in agriculture, domestic use, industry. In agriculture, in the rural area, they use rainwater harvesting, and most of the agriculture in rural area, it is happen in rainwater harvesting. And domestic use we can also use, and industry, like there is in our industry we can use also rainwater harvesting for their purpose. Next slide. That is groundwater recharge. And groundwater recharge is a hydrologic technique in which water steps downward from floor water to groundwater. And the procedure normally takes place inside the Dhados region underneath plant roots. And you can refer this diagram. Next slide, please. That is a method of estimation methods of groundwater recharge. That is physical, chemical, numerical methods. In physical technique use ethics of soil physics to calculate recharge, and in chemical section, chemical technique use the presence of noticeability intact water solution material collectively in an isotopic tracer. And in numerical methods, we are rating of landfall success. And that is, we also use various type of application like unset H, so wave, and MIC, and that is also used. Next slide, please. That is the main our
Tanmay,
topic.
Please come to the conclusion. Okay.
Okay. 1 minute. So final, that is our conclusion. It is terrific time to inspect irrigation control, and water is needed for necessary for our universe. So that's why we should conserve the water, and also do not waste the water. So water conservation is an innovative idea for the duration of the sector, and one that have to not to taken slowly. And that is new tendency generation are supporting to make this procedure great deal less difficult than ever before. So thank you everyone.
Thank you so much, Tanmay. I'm really thankful to you because you are in the office right now and you are giving the presentation out there. I would request the audience, if you have any question, I can take a single question. Please, anyone? Niranjan once again. Okay, it should be a very small question, Niranjan. Yes.
Okay, sir. Sir, I ask a question. Can we set up a STP at every small or big project? Can we save the water with making the STP with every big and small project?
We can in the project we save water, but we have to in a necessary we use the water, because we our main purpose is to save the water. So when in our industry we need the water, we should use water. And apart from that, we when
the use water, we can use water through the use water. We can treatment and reuse that water at the sewage treatment plant. We make the sewage treatment plant at every project.
Yes. It is possible. Yes.
Thank you very
Okay,
much.
thank you so much.
Okay, thank you.
Tanmay, thank you once again. I'll be going to the next presentation.
Thank you everyone. Okay, bye.
Yeah. I'll be going to the next presentation, and the title of the paper is Assessment of Water Quality Parameters in Kamle District, Arunachal Pradesh, India, and authored by Bini Kiran, Dr. Sudeep Basak, and Krita Goswami. I think Professor Bini Kiran is already with us. Over to Professor Kiran. Yes.
Hello, is my voice audible?
Yes, yes, audible.
Okay. First of all, good afternoon to everyone. And I would like to thank the Principal ECE, Professor Sudeep Basak, and my dear colleague Goswami for giving me the opportunity to be part of the conference. So I shall begin my presentation now. Wait. So the topic is assessment of water quality parameters in Kamle district. Is it visible?
Yes, visible.
The topic is assessment of water quality parameters in Kamle district, Arunachal Pradesh, India. And here goes the contents. First is I will give the introduction and water quality parameters, materials and methodology, location and sampling, water quality index status, conclusion, and references. The first is introduction. Water quality assessment is defined as the evaluation of physical, chemical, and biological nature of water in relation to the natural quality, human effects, and intended uses. Water index provides information about water quality in a single value. Water quality index based on hydrochemical data. This is the introduction. Here are the parameters to calculate the water quality index, which includes pH, temperature, dissolved oxygen, total dissolved solid, nitrate, phosphate, and turbidity. Here is the materials and methodology. Here I have used three materials to calculate the said parameters. First is exact micro 20, which can be obtained from online or nearby shop as well. And this is the picture of my exact micrometer 20. It's quite simple to use if we follow the instruction manual. And here's the second instrument which I used to calculate pH, ORP, DO, CD, TDS, etc. And here's the location and sampling. As you know, Arunachal Pradesh is the easternmost part of the India, and it's include 25 districts. And Kamle district is the smallest of that 25 districts. And personally, I belong to Kamle district, so I have chosen this topic. Sampling. Water testing were carried out in 40 different locations in Kamle district of Arunachal Pradesh. Tests were done in situ with the help of testing kit. Testing kits are those devices which are used to obtain the values to calculate the WQI. On spring water and river water, and the data were noted. Sample to be named has state, district, source, sample, number. Here, for example, AP stands for Arunachal Pradesh, K stands for Kamle, SW is spring water, and there is also RW, which stands for river water. And 001 number system is to represent the places on which I have I have noted the data. And water sample have been collected for both post-monsoon 2019 and pre-monsoon season 2020. Water quality index. Water quality index is the mean by which water quality data is summarized for reporting to the public in a consistent manner. Calculation of WQR was carried out in this work by National Sanitation Foundation method. Basically, there are 3 to 4 different methods available that are, sorry, I forgot the names, but there are 3 which are like this. Sorry, I forgot that. My apology. Dissolved oxygen, pH, temperature, phosphate, nitrogen, nitrate, turbidity, and total dissolved solid are the parameters used. Due to unforeseen condition, other parameters such as fecal coli and biological oxygen demand were eliminated. The WQI values were calculated with the help of an online calculator, which is available in the internet. These are the range by which we can, represent how good the water quality is. 90 to 100 represent excellent. 70 to 90 gives us good quality of water. 50 to 70 represent medium. 25 to 50 bad, and 0 to 25 very bad. WQI status. This is the result which I have shown in a graphical manner. So it's given that percentage water samples has per water quality status for pre and post monsoon season. Conclusion. The water quality of the study area during pre-monsoon and post-monsoon season were analyzed as per NSF method. The quality of spring water is far better than river water. For the post-monsoon period, 98% of water sample are in good condition and 2% falls within the medium range. For the pre-monsoon period, 93% of water sample are in good condition, 7% falls within the medium range. The variation in WQI primarily due to unpredictable high rainfall. Average WQI for post-monsoon is higher than that of pre-monsoon period. Here are the references, and thank you.
Thank you so much, Professor Kiran. I would like to request the audience, if they have any question, they may raise their hand. Anyone? The judges, if you wish to make any comment.
Yeah,
Okay. Okay, sir. Okay. Okay, then once again, I wish to thank Professor Bini Kiran. I'll be going to the next presentation. The topic is experimental investigation on the impact of sulfate and chloride on high volume fly ash concrete. The authors are Dinken Paksok and Ravi Patil. I think Professor Paksok, he is already present right here. Web hosts. Yes, Professor Paksok, he is already present. Okay, over to you, sir. Yes, sir, you are absolutely audible. Yes, you are absolutely audible. Okay. Now you are not audible. Jeet sir, is he audible? Yes, PPT is visible.
This PPT is visible.
Yes, slides are visible, but not full screen. I don't understand. I cannot hear his voice. It's broken. Your voice is breaking. No, your voice is breaking, but your screen is visible. You are visible, but your voice is breaking. No, it's same. I think it's a kind of network issues or something like that. Gautam sir and Jeet sir, can we help him? How can I help him?
Sir can plug to where
Ask her to rejoin. Okay.
Okay.
you can use word headphone.
Okay, Mr. Paxsock, you can do something. You please leave the session and you please rejoin. Please leave the session and rejoin. You are visible, your screen is visible, but your voice is not audible.
Sir, you can use word headphone.
Maybe sir can check his sound settings. Maybe he got muted.
Okay, then we are doing something is Mr. Deepak Kumar Paurel is present on this platform.
Yes, he is present.
Mr. Paurel has joined. We can yes, we can go to the next presentation and let Mr. Paxok to prepare everything, then we'll give him another chance. Okay, so we are going to the next presentation, that is leachate characteristics and its treatment technique, a review, authored by Deepak Kumar Paurel and Dinken Paxok. Okay, so if Mr. Paurel is present on this platform, please unmute yourself. Mr. Deepak Kumar Paurel is present on this platform.
Yeah, ma'am, he is present.
Okay, please unmute him.
Yeah, he is unmuted.
But again, we cannot hear him. But I cannot even find him right here. Okay. Mr. Deepak Kumar Paurel, can you hear me? I think they both have the same problem. Yes, we can see the screen of Mr. Deepak Kumar Paurel. So let's listen this presentation, and after that we'll be listening the presentation that we have already left. So over to Mr. Deepak Kumar Paurel. Sir, please. Start your presentation, please. Sir, sound is not. Voice.
Hello.
Yes, you are audible.
Thank you, ma'am. Hello. Ma'am, my voice is audible?
Yes, audible.
Thank you, ma'am. First of all, I would like to express my hearty gratitude toward all the organizing members who have organized such a wonderful conference. My name is Deepak Kumar Paurel. I am a student of Northeastern Regional Institute of Science and Technology. So my topic is leachate characteristics and its treatment technique. So these are the contents. First, introduction, will in introduction will know about leachate, and in next topic we'll discuss about effect of leachate, and in another topic we'll discuss about the composition and characteristics of leachate. Again, in leachate control techniques and treatment process. So first thing, what is leachate? Leachate actually, before I'm going to leachate, first let me give you an overview. Actually, the issue of waste management has existed since dawn of time. Our environment is deteriorating day by day as a result of fast industrialization and population growth. So leachate is a polluted effluent that is extremely complicated. Its quality is determined by biological, chemical, physical processes in landfills, as well as the waste composition and water regime in the landfill. So in simple terms, the liquid that drains or leaches from a landfill is known as leachate. Landfill leachate is generated by excess rainwater percolating through the waste layer in a landfill. Leachate are a great danger to the underground water, especially those that are built close to the dump site, landfill and waste dumping areas. So there are certain effects of landfill leachate, which are first, leachate comprises a variety of hazardous and carcinogenic compounds that can harm the human and environment. So there are certain heavy metals which or carcinogenic element which are present in leachate. Some of them are lead. One of them are lead. So lead is basically it affect the human. So few I'm so sorry. Few compounds are lead, mercury, cadmium compound, nickel, etc. So leachate contain groundwater that can adversely affect industrial and agricultural activities that depend on well water. So the use of contaminated water for irrigation can decrease the soil productivity, contaminate crops, and move possibly toxic pollutant up to the food chain and animal and humans. So some of the medical literature tell us the general health condition caused by consuming the leachate contaminated water can range from sweating, bleeding, stomach disorder to blood disorder, congenital disabilities, and even cancer. So some of the elements which can cause this disease are lead. So lead can cause abdominal pain, diarrhea, vomiting, and mercury. One of the compound present in leachate water is mercury, which is also responsible for bloody diarrhea and dehydration, and also cadmium compound, which affect like chest pain, cough, and skin irritation, etc. So composition of leachate. Leachate is typically contains a substantial volume of organic matter as well as ammonia, nitrogen, heavy metals, chlorinated organic and inorganic salt. So landfill are divided into three categories: young, which is less than 5 years, intermediate, which is around 5 to 10 years, and old, which is more than 10 years. So pH ranges from, in young leachate, the pH should be pH ranges to 6.5. In intermediate, it is 6.5 to 7.5, and in old, it is more than 7.5. And COD, milligram per liter, which is more than in young leachate, it is more than 10,000. In intermediate, it is 4,000 to 10,000, and in old, it is less than 4,000. BOD and COD compound present is in young leachate, it is more than 0.3%. In intermediate, it is 0.1 to 0.3, and in old, it is less than 0.1. organic compound present in young leachate is 80% of the volatile fat acids, and in intermediate 5 to 30% of volatile fat acid, humic and fulvic acid. In old leachate, humic and fulvic acid is present. Heavy metal present in young leachate are very low. In intermediate leachate is also low, and in old leachate is also low. So there are a concentration of landfill leachate comparing with sewage and groundwater is present in the COD commerce. The COD in young leachate is 20,000 to 40,000, where in old leachate it is 500 to 3,000. In typical sewage concentration it is 300, and it in typical groundwater concentration it is 20. So like that, BOD is also 10,000 to 20,000 in young leachate. Old leachate concentration 550 to 100. Typical sewage concentration is 250, and in groundwater concentration it is 0. Like TOC in young leachate it is 9,000 to 25,000. In old leachate it is 100 to 1,000. Typical sewage concentration is 100, and in typical groundwater concentration it is 5. So volatile fatty acid present in the young leachate concentration is 9,000 to 25,000. In old leachate concentration 550 to 100, and typical sewage concentration it is 50, and typical groundwater concentration it is 0. So leachate control. So the passage of leachate into groundwater is controlled by developing lining system that ensure minimal permeability. Leachate collection system are installed above the liner and usually consist of piping system sloped to drain to a central collection point where pump is located. Once the leachate has been collected and removed from the landfill, it must undergo some treatment and disposal. So there are few leachate treatment process we'll discuss. The first is biological process. Biological treatment involves maintaining the conditions required for optimal growth of the microorganisms. Microorganisms transport the colloidal dissolved carbonaceous organic material and inorganic element like phosphorus, potassium, calcium, and magnesium into its cell. The majority of the biological treatment procedures are built up by interconnected mixed biological populations that have been tailored to remove the certain pollutant. So one of first under biological treatment process, that is anaerobic treatment process. So what is anaerobic treatment process is during the period of high organic concentration in leachate from the landfill acidogenic phase, an anaerobic treatment step could be used to reduce the major qualities of degradable organics. The main benefit of okay, ma'am. So the main benefit of anaerobic treatment method is it required very little energy because no oxygen is required. In aerated lagoons, the aerated lagoons are simple solution for treating leachate. The underlying idea is that the leachate is retention during the long enough so many bacteria can grow as per unit time. In activated sludge plant, the detention time is typically much shorter than aerated lagoons. The reason for this is that the sludge content can be managed by in aerated lagoons. It is several times higher. Okay, in rotating RBC, the bacteria is linked to the material of the spinning contractor or the filter in the tickling filters. Now, physicochemical treatment process, when the biological and biological process is inhibited by the presence of biorefractory materials, physicochemical techniques are employed in conjunction with the biological matter to improve the treatment efficiency or to make them possible. So first, coagulation and flocculation. In several studies focused into coagulation flocculation for the treatment of landfill leachate, with the goal of improving the performance, such as selecting the best coagulant, determining the experimental settings, assessing the pH effect, and investigating the flocculant additions. In adsorption, for landfill leachate treatment, the adsorption process is used as a stage in integrated chemical, physical, and biological process. Granular or powder activated carbon is the most commonly utilized absorbent. As a result, the goal of activated carbon absorption is to ensure the final polishing element by harmful heavy metal or organics. In membrane filtration, a membrane process include using a semi-permeable membrane to separate two concentration. So, conclusion, the problem of the leachate treatment has persisted in various countries for some time, but no uniform solution has been established. The following, these are the treatment technologies like biological, physical, and chemical processes. But however, in order to achieve good quality or standard for direct leachate discharge into the surface water, integrated treatment system, it should include combination of physical, chemical, and biological stages must be developed. Thank you.
Thank you so much, sir. It was really a wonderful and informative presentation. I would request the audience if they wish to ask any question. Anyone? Okay, I'm moving to the last presentation of this session. I think Mr. Dinken Paksok, he has joined once again. Sir, are you there? Yes, yes,
Yes.
please. Okay, okay.
Am I audible? Really audible now?
Yes, yes, you are absolutely audible.
Okay. I'm I'm very thankful to all the organizing teams actually. Okay. So you can see my screen now.
Yes, we can see. Yes, your presentation also. Okay. Please make it full screen. Yes. Okay,
Yes.
sir. Please start.
So actually, I would like to thank each and everyone who has been here patiently waiting for my presentation. Due to some technical glitches, I could not, proceed with my program earlier. And I would like to thank especially the convener and convener Mahuya Madam ji and Basak sir for having the patience with me. So my topic here is about the experimental investigation on the impact of sulfate and chloride on high volume fly ash concrete. Okay, so these are the contents I'll be talking about. First is the introduction, then I will have the material and methodology discussion. After that, I will show you the results and then my conclusions on my own and then the references. So in the modern era, we have noticed that fly ash has been generated abundantly in the environment, but there is no proper use of this material. But we as a civil engineer, we know that these fly ash, they are pozzolanic material, and as such they possess strong binding capacity in them. Okay, so in my investigation or the experiment, I have used the class F fly ash, which is the most common and abundant and easy to procure form of fly ash in the market. So and first of all, let's learn about the sulfate and chloride attack also. So what sulfate does is, sulfate molecules, they enter into the concrete, and after that they combine with the calcium hydroxide. Okay, it's present in our concrete. Okay, and what happens with the hydration, and in hydration with them, they form calcium sulfate. In common term, we call it gypsum. Okay, and after that, this aluminate compound from the Portland cement will further react and form ettringite. Ettringite is a material, a solid crystalline material that develops inside our concretes in time. Okay, and that is very harmful for our concrete structures. Next is chloride. Chloride basically doesn't actually attack the concrete, as per my findings. It just penetrates into the concrete and then goes on to attack the reinforcement actually. What happens? Reinforcement, it starts corroding them. And then in corrosion, these reinforcement materials, they expand outwards on all sides. And after that, what happens? This on expansion, these materials, they will rather have pressure on the side walls of the, this reinforcement, and as such, the concrete start bulking in that area. And now materials. So as you can see, these are the materials I have been using, and been using it as per the Indian standard requirement. The ordinary Portland cement that was used was 43 grade, conforming to IS 8112 of 1989. Then I have used the fine aggregates of natural sand with a 4.75 mm maximum size, and it was conformed to IS 383 1970. Then we have coarse aggregate used in the project, which was 20 mm nominal size, and it was conforming to IS 383 of 1970. And then we have the fly ash, as we all know that I've been using this, this super plasticizer, okay, because the work, theoretical work and practical work are different. Because theoretically, when we add water to the, the concrete mix, what happens is that the amount of water, theoretical, is not sufficient in practical, okay. So I've been using super plasticizer to, to help with that. And the super plasticizer used was super plasticizer for Fosroc Conflast SP 430 DIS, okay. Then we have the to simulate the acid attack, a pH of 5 was maintained in the curing tank. First I made a pit of that, and in that pit I, after testing in the lab per 1,000 liters in the lab, I have used this sulfuric and chloride acid in the lab. After confirming that, we used it in the this curing tank, so as to simulate the acid attack, okay, on the concrete. And mix design that was made was confirmed to IS 456 2006 2000 and IS 10262 2009. So here what happens, first we prepared an M30 grade of concrete successively by replacing the the sand rather than the fine aggregates. In other way, we can say that I've been increasing the binding material of the concrete, okay. So the replacement was as per 0, 10, 20, 30, 40, 50, as such and such till 100%. And then what happened after mixing that, I did the slump test. I carried out the compaction factor test of the mix. Then this all concrete were then put into this cube molds, okay, of dimension, standard dimensions as per the IS 150 into 150 into 154. These are for compressive strength test. And then in the beam molds, okay, which are of dimension 700 into 150 into 150. These are for flexural strength test. Half of the molds means 3 moles of 3 moles of each were used in placed in what we call that 3 iterations, in a way we can say that 3 iterations of the molds were placed in the curing tank. One like 10% replacement were placed in in curing tanks that has been conforming to H2SO4 at a pH of 5, and the other one was in HCl, and they were placed in there that for about 28 days as per the requirement for curing. So this
last minute, sir.
This will simulate the this acid attack and acid attack on those materials. Then the cubes were subjected to compressive strength and flexural strength test. So these were the result, okay, as per the test conducted. These were the result that have been that we have got. And as said, from this graph, I have drawn out the conclusions. Actually, the conclusions are that the compaction factor reaches the peak value of 0.4 with a slump value of 56 at 30% replacement of fine aggregates by fly ash. Okay, and then there is highest workability of 30% of the fine aggregates by fly ash. Then we have characteristic strength to be found for both the cases. Okay, in sulfate attack and chloride attack at 30% fine aggregate replacement. The maximum compressive strength under the chloride attack is at 30%. Similarly, is in the case of sulfate attack, but the values are different. For chloride attack, it is 38.83 MPa Pascal, and for the sulfate attack, the value is 39.01 MPa. The maximum flexural strength under the similarly of all the results, it has been found that 30% fine aggregate has been the optimum. The maximum flexural strength has been found to be 13.03 MPa for 30% fine aggregate replacement. Similarly, in the sulfate attack also, it's 13.85 MPa. But it has been observed that more resistant to sulfate attack than the chloride attack, those concretes. The result of the investigation suggests that partial replacement of 30% for the replacement of fine aggregates by fly ash is optimum. And these are the references I have from which I have drawn the experiment actually. Thank you so much.
Thank you so much, sir, for your enlightening speech. Here I would like to request our judge, Professor Dr. Ashwini Kumar Sharma, if you wish to make any comment.
Yeah, ma'am, that's okay. I think I'm with this. Nice presentation.
Okay. So thank you, Mr. Paxok, once again. Sir, it was the last session actually. Now I would request, it was actually our last presentation for this session. Now I would request our honorable judges, specifically Dr. Ashwini Kumar Sharma, I would request sir if you would like to make any comment, just overall on all the presentations, if you would like to make any comment.
Yeah, that's right. There are a number of deliberations which has taken place in this session of civil engineering, and the scholars, they have put up, they have taken up the different fields and the civil engineering to invade into. So it's starting from rainwater harvesting to ultrafiltration of toxic effluents, laboratory investigation of flow traits in saturated clay, assessment of water quality, experimental investigation into sulfate and chloride, and leachate characteristics. So yes, they have touched upon the very pertinent questions which are arising nowadays, especially with the water quality. And I'm happy that they are working into this field, and somehow in coming times they will come through a big breakthrough where they can suggest sustainable water treatment or water technologies, because the government is spending so much nowadays for this, and we need it. So thank you so much for coming on to this forum, and best wishes.
Thank you, sir. I would like to request Professor Abhijit Karmakar if you just wish to make any comment.
Yes, thank you, ma'am. Actually, all presentation was very good, and the participants were very much interested. And few presentation also is very much upgraded, and overall presentation is fine. Thank you, ma'am.
Okay, thank you so much, sir. Both of you, lot of thanks to you because of your valuable comments. Now, I would like to request our session chair, Professor Dr. Krishna Hajra, ma'am, if you just wish to wrap up the session just by summing up all the presentations. Please, ma'am, over to you.
May I audible?
Yes, ma'am. Yes.
Thank you, Professor Mahua. Before I sum up this session, I would like to thank Professor Dr. Sudhir Bosak for his informative and relevant keynote address. Thank you for your wonderful presentation, sir. We had this session 7 informative presentations. These are provision and scope of rainwater harvesting at Elite College of Engineering by Ms. Shushmita Halda, membrane-based ultra-filtration of toxic effluent to combat groundwater crisis by Mr. Proloy Kumar Ghosh, the laboratory investigation on flow traits in saturated clay by Mr. Gitartho Goswami, implementation of water science and technology by Mr. Tanmay Khatwa, assessment of water quality parameters in Kamle district, Arunachal Pradesh, India by Mr. Bini Kiran, leachate characteristic and treatment techniques, a review by Mr. Deepak Kumar Orel, experimental investigation of the impact of sulphate and chloride on high volume fly ash concrete by Mr. Dinken Paxo. I thank and appreciate all of them for sharing this knowledge with us. We are really now richer by our knowledge. I am also grateful to Professor Dr. Ashwini Kumar Sharma and Professor Abhijit Kormukar for taking their share of the judges in this session and giving their valued opinion and verdict on the quality and overall relevance of the papers presented in this session. Finally, I should really thank moderator Professor Muhammad Datta and our host Mr. Jit Viswas for beautifully conducting the session. And with this, I want to declare this session to be concluded. Thanks to everyone who are present and given a good ear. Thanks.
Thank you so much, ma'am. So, audience, I think you are all very hungry right now. Okay, so we will be meeting again just at 2:37. Okay, just half an hour I can spare, and so 2:37 at just 2:37. Not 2:37, sir. It is getting 1 hour. Actually, 2:07. Okay, at 2:07 we'll be meeting again for technical session 4. And till then, I am signing off with my web host Professor Gautam Das and Mr. Jit Viswas. So again, I'm coming on this platform at 2:07, just at 2:07. Okay. So till then, goodbye.